All right, here we are back with the chapter review. This is part 2. We're going to look at a few more questions here. How to graph this. There's a couple ways you can do it. Either use intercepts, or our most favorite way to do this, put it in slope-intercept form. So subtract 2x from each side, and then we get negative 3y is equal to negative 2x plus 9. Okay, this over here was supposed to be a 3. Divide by negative 3. All right, and then we get y is equal to, negative divided by negative is positive, 2/3 x minus 3. So our y-intercept is negative 3. Put a dot there. Our slope is up 2 over 3. Up 2 over 3. Over is always to the right. We read and write from left to right, so we graph the same way. And then put a line that goes through those points. Not just to the points, but through those points. All right, and there is that graph. Notice that this one doesn't have an x, so we already know this is going to be a horizontal line. Add 4 to each side, and then we get negative 2y is equal to 8. That was supposed to be a negative over here. Divide by negative 2 on each side. And then y is equal to negative 4. So that's the same as saying y is equal to 0x minus 4. All right, so it goes through negative 4. 0x means it doesn't go up, doesn't go down. There's no x, so this is a horizontal line. This graph looks like this, going through 4 on the y-axis. That is a 0 slope. Horizontal line. All right, we have this function. C is the cost and M is the miles. Identify independent and dependent. Now, independent are the x values. In this case, the x value is the M, so that is the miles. Miles M. The independent values represent miles M. Dependent is the cost C. All right, because that is the y in this case. Y equals mx plus b. What would the cost be to rent the car and drive 100 miles? So now I'd plug in 100 here. I'd get 30. The cost would be 130. How many miles would a customer have to drive? Now I will plug this in for C up here. So then I'd set that up like this. 0.5 is equal to 100 plus 0.3 m, and solve for m. I'm not going to do that. I know you can. All right, use the graphs f and g to describe the transformation. All right, from f to g. So I don't really need this right here. I need this. Okay, remember inside the parentheses was horizontal. Okay, so this is a horizontal reflection. Horizontal reflection means it goes across the y-axis. So this is a reflection across the y-axis. Reflection across the y-axis. And then we can look at the graph to see, is that true? Did this point get reflected across the y-axis to over here? Yes, it did. This point got reflected across the y-axis. Yes. All right, reflection across the y-axis. Here, again, we are not so much interested because we're just looking at the transformation. We're not so much interested in this part. We want to see how did it change. So we want to know this part right here. Inside the parentheses, horizontal, outside vertical. So this is vertical. It's a multiplication, so it is a vertical, and that's going to be a stretch or a, sorry about that, stretch or shrink. And that is a vertical shrink because 1/2 makes it smaller. Okay, vertical shrink of 1/2, factor by a factor of 1/2. Okay. Describe the transformation. All right, so here's quite a lot going on. The transformation first. Inside here, we have a horizontal move. Okay, so right there, we have a horizontal move right 1 unit. Okay. Horizontal move, right because remember, inside the absolute value bars, things aren't quite as they seem. Right 1 unit. This is vertical move, so a translation. This is a translation up 2 units. Here this, we're multiplying, it's outside, so it's a vertical stretch because it's multiplying by more than 1 by a factor of 2. And then this right here is a reflection. Reflection across. Now remember, that's a vertical because it's outside. Vertical reflection, so it goes up and down, which means it goes across the x-axis. Across x-axis. All right, that's all the transformations. Up 2 units, horizontal means right 2 units, vertical stretch by factor of 2, and reflection across the x-axis. Now it says to graph the g. F of the absolute value of x. The parent function is this. Okay. Notice that this is written in vertex form. So we have h and k, h and k, h and k are 1 and 2. That is our vertex, h and k. So at 1 and 2, different color here, 1 up 2. Now, the slope is this out here, a, all right, and that's -2. So on the right side, we go down 2 over 1, down 2 over 1. And then we reflect that across the line of the vertex, down 2 over 1, and that looks like this. Please use a straight edge. I can't on this board, but that looks like this. Now we check to see, does that correspond to what we said here? Up 2 units, up 2 units, right 1 unit, right 1 unit, yep. Vertical stretch, so it got pulled, which means it got narrower, and then reflection across the x-axis, so reflected down. Right? Okay, that's exactly what we have. All right, and then number 27. Here we have evaluate this when x is -1. Okay, -1 is less than 2. So it fulfills this right here, which means that I use this one. -2 times -1 minus 1. So that's f of -1 equals this. -2 times -1 is 2, minus 1 is 1. F of -1 is 1. If x is 4, that is greater than 2, so I'm going to plug it into this one. So f of 4 is negative, parentheses here, when we replace a variable with a value, put it in parentheses, 4 plus 4. -4 plus 4 is zippity-doo-dah, 0. So f of 4 is 0. And there you have it, ladies and gentlemen. Good times. Study, study, study. Come prepared. You can do it.